Hi, and welcome to this lesson on deriving and using law of signs. It's part of a 3-day lesson in which first we'll use the law of signs on some really simple examples where there's no issues. And then second, we'll talk about when law of signs can be ambiguous and how that will change the route you will take to solve your problems. And then third, we'll learn how to do a special kind of problem. I like to call it a tree on a hill problem that can be solved using law of signs. So we're going to start with going back to what we did before, using area with sign. We learned that for a right triangle, or for a triangle, there's the triangle, same exact triangle we used, ABC, with sides of A, B, and C, that the area with sign says that you can do 1/2 times B times C times sine of A, the angle between them. This works for side angle side. Or you could do 1/2 times A times B times sine of the angle between C. Or you could do 1/2 times A times C times sine of the angle B, depending on which two sides and which included angle between the two sides on the triangle that you actually know the value of. So you can think of this as an equation with like 3 sides because the area of the triangle will remain the same regardless of which two sides and angle you use to find its area. What we're going to do is take this area with sign and use it to get a law of signs for the triangle. We are going to divide each of these expressions by 1/2 ABC and see what happens. Well, on this one, the 1/2s cancel out, the B's cancel out, the C's cancel out, and you're left with sine of A divided by A. On this one, of course, the 1/2s cancel, the A's cancel, the B's cancel, and you're left with sine of C over C. And on this one, the 1/2s cancel, the A's cancel, the C's cancel. You're left with sine of B over B. This is what we call the law of signs. The sine of A over A, so if you have the sine of angle A over little a, it's going to be the same ratio as the sine of C over C, as the sine of B over B. So it's kind of a proportion with 3 sides that you can use to find unknown sides or unknown angles of a triangle. If you know 2 sides and an angle, and you can set up a proportion, either these 2 equal, or these 2 equal, or those 2 equal, you can solve for the unknown side or the unknown angle. Let's look at this in a simple example here. Okay, we're going to draw our own picture. We have triangle XYZ. So I'm just going to draw and label a generic triangle, not to scale, XYZ. And we want to find x to the nearest 10th. That's a lowercase x, so it's the side. Y is 4. Measure of angle x is 37. And measure of angle y is 65. So we're going to check, can we set up a law of signs? We have a side and an opposite angle. And we have a side and an opposite angle, and one of those 4 things is unknown. So yes, you can do sine of y over little y equals sine of x over little x and solve. So sine of 65 over 4 will equal sine of 37 over x, and we can cross multiply to solve this proportion. X sine 65 equals 4 sine 37, or x equals 4 sine 37 divided by, oops, I forgot sine of 65. So that's where we take our calculator and work it out. 4 sine 37, and then I'm just going to divide that by sine of 65, and I see that my unknown, oh, I forgot to divide. I just typed it in. Let's try this again. 4 sine 37 divided by sine of 65. That's better. That's 2.7. So x is approximately 2.7 units. And you can kind of check for reasonableness here because we have a smaller angle with a smaller opposite side than the larger angle, which has a larger opposite side. So it kind of makes sense. And there's our unknown side length. Now, in the next example, I want you to try one. We have triangle ABC. Draw a picture and label it up, or do it on the copy if you did the printout. Triangle ABC, little a, side A is 16. The angle A opposite it is 40, and angle B is 58. You're going to find the side little b to the nearest 10. So pause the video, give it a try, and come back and check. So if I draw my own picture here, A, B, C, little a is 16, angle A is 40, angle B is 58, little side B is what we're going to find. So I'm going to set up my proportion of sine of 58 over B equals sine of 40 over 16. Cross multiplying and dividing, 16 sine of 58 divided by sine of 40 will give us what side B is. 16 sine of 58 divided by sine of 40. B is approximately 21.1 units. We don't have any units in this problem, but we did solve for B. So I hope you got that one correct. All right, in our next example, we're going to actually solve a triangle. And from our right triangle trig unit, we should remember that solving a triangle means you are not going to stop until all the sides and all the angles are known or labeled. So I'll draw a picture of the situation they've given us. This one's just for you to watch. Triangle ABC, little a is 8, angle B is 120. So you can see my picture is not to scale, but that does not matter because we just need relationships to help us set up the proportions. It says solve the triangle. It doesn't tell us which side or angle to find first. Now we're using law of sines because that's all we've got right now. So we know we're going to do sine of 25 over 8 because that's an angle on the opposite side. Since we know the 120, we'll do sine of 120, and it looks like we're going to find this side first. So we're going to cross multiply and solve that proportion. Of course, you see the 120, your mind should go to special right angles because it has a reference angle of 60. But we're going to have to go decimal on this anyway, so we're not going to be really worrying about getting exact answers with radicals when we're doing law of sines and law of cosines, unless they magically give us a right triangle. 8 sine 120 divided by sine 25 will give us the length for B. Okay, so 8 sine 120 is about 6.92. I'm going to divide that by sine of 25. So B is approximately 16.4 in length, whatever units those are. Okay, solving the triangle, we're not going to quit until we're done with all the sides and angles. So if I take my calculator and I'm going to subtract, well, this is 120, this is 25, that's 145, which means if you do 180 minus 145, you should get 35 degrees for the unknown angle here. And then I can set up another law of sines to get this missing side, C. Sine of 25 over 8. I'm using that one because it doesn't contain a rounded number. So sine of 35 over C. We'll cross multiply and divide. 8 times sine 35 divided by sine 25 should give us C. Okay. Oh, I didn't divide it. 8 sine of 35 is approximately 4.58. I'm going to divide that by sine of 25 and get about 10.9. All right, so if I do that, I get my value for C. C is about 10.9. The triangle is solved, so we know all three sides, all three angles, we're done. In the next example, you're going to try solving a triangle yourself. Find all the sides and all the angles, pause the video, and then come back to check your answer. triangle ABC, A is 80, B is 60, and angle A is 52. All right, so A is 80, B is 60, measure angle A is 52. Now on this one, it looks like I'm going to be finding an angle first, maybe angle B because it's opposite the 60. So sine of B over 60 equals sine of 52 over 80. Since we're going to find angle B, it looks like we're going to be using an inverse trig function at the end. 60 sine 52 over 80 will give us the sine of angle B. 60 sine of 52, that's 47.28 about. I'm going to divide that by 80, and I get that sine of angle B is approximately 0.5910. So to get the measure of angle B, if you remember from our trig unit, you do sine inverse of 0.5910. And that will give us that angle B is about 36.2 degrees. So we got that one. So to get angle C, we'll just subtract from 180. 180, subtract 52 minus 36.2. We get about 91.8, very close to being a right triangle here. So now I only need to solve for C to get the triangle all solved. So I'm going to set up another law of sines. Sine 52 over 80, sine 91.8 over C. So I do 80 sine 91.8 divided by sine of 52 to get what side C is, lowercase c. 80 sine 91.8, and I'm going to divide it by sine of 52. Oh, I didn't divide. I keep doing that. I type it in and I don't divide. Sine 91.8 divided by sine of 52. C is approximately 101.5. Let's check our answers. Reasonable. Largest side, opposite largest, opposite angle. Okay, middle side, opposite middle sized angle. And smallest side is opposite smallest angle. So our answer is reasonable and the triangle is solved. Okay, so we're done doing examples where we practice using law of sines. Let's do a couple of problems that'll kind of summarize it and lead us into what we're going to be learning next. Why would you have a problem solving the triangle here if I asked you to? Okay, so as soon as it stops being fuzzy, you can see you have a triangle. You have an angle and an opposite side. You have an opposite side. We could set up and solve for angle B. We could do a sine equation for that. Sine of B over 9 equals sine of 37 over C. So mechanically, and C is 7, we can set up a proportion with law of sines. The algebra will work. We can solve for B, but why do we have an issue doing this? Did anybody recognize that you have two sides and a non-included angle? That's angle side side. And when we developed our triangle congruence criteria, oh, that's a horrible circle, back in the earlier units of the year, we talked about this picture. A, B, C, D. This triangle is not the same as this one. But we talked about how you can have two triangles which have angle, side, side, congruence, correspondence, triangle ABC, and triangle ABD, because these are both radii of a circle. Both share two sides that are equal and an angle outside of those two sides that are equal. So we're not paying attention to this right now. We're looking at triangle ABC, which has angle side side, and ABD, which has angle side side. But obviously those two triangles are not congruent. One is obtuse and, well, they're both obtuse actually. And they include, one triangle includes this area of this isosceles triangle, and so has a way bigger area. They are not congruent. Okay, it's possible they are congruent. It's possible that you could have a triangle with angle side side and it be congruent. And we talked about that if the triangle happens to have the other angle, like we moved this, I did it on Sketchpad, and if you get a right triangle, then you do have two triangles with angle side side that are congruent, which we called that hypotenuse leg. But it doesn't work for all triangles. So once you get to a triangle with two sides and an angle not between them, and we can set up a law of sines and solve it, we have to worry about if there are two different triangles or if there's just one triangle, and this triangle happens to be a right triangle where this other angle happens to be a right angle. Maybe it is, maybe it isn't. So this is where we get to the ambiguous case. It's possible that you can't create any triangles. You can create one triangle, or you can create two triangles. So, you know, if one of these problems accidentally ends up in your homework, just solve it for now. But then we'll talk about, oh my gosh, this could be ambiguous. We could have more than one triangle possible, and we'll get to that in our next lesson. Okay. I just want to prepare you that that's coming up. Law of sines has issues sometimes. All right, finally, let's summarize. I'm going to give you the directions for this. I think you should pause the video and do it on your own, and then maybe come back after when I tell you to. So listen for that to come up. For each triangle below, do the following two things. We're kind of summarizing here. Label which triangle congruence correspondence it fits. So have I given you 3 sides, SAS, 2 sides and a non-included angle, 2 angles and an included side, 2 angles and a non-included side, or 3 angles? Which one would it fit? So in other words, would this triangle be congruent to every other triangle that's labeled like this? And then 2, write yes or no as to whether or not we can set up a law of sines. Do we have a situation in which we do a sine of an angle over opposite side, sine of an angle over opposite side, and we get only one unknown in that proportion that we could solve? All right, and then after we do that, we'll kind of summarize at the bottom. So let's look at the first one. I have an angle and I have 2 sides. Could I set up a law of sines proportion? And what triangles correspondence does this fit? I have a side, and an angle. This is definitely side, angle, side. Okay. Could I set up a proportion to solve for something on the triangle? Okay, well, I have side, angle, side. In order to use this, I would need to know this angle or be finding that angle. In order to know this, I would need to be using or know that side of the angle. 52 and C. I have nothing. I don't even have one pair of opposite side with opposite angle that I know. Sine of 52 over C, that's the only angle I know. And sine of B over 13, that would have 2 unknowns. Sine of 52 over C, sine of A over 5, that would have 2 unknowns. So no, I cannot use law of sines on this triangle. All right, this is a good time for you to pause the video and go over the other 5 and then come back and see if you got them all right. Okay, so if I look at the next example, an angle, a side between, ASA. Could I set up a law of sines? Let's see. Sine of 52 over C. Sine of B over 13. Sine of 49 over A. At first glance, it's like, no, because no matter which 2 of these I use, I do not have a proportion in which I have only one unknown. 2 unknowns, 2 unknowns. If I use these 2 and mark out the middle, 2 unknowns. However, this is a triangle. I know 2 angles, which means I automatically know the third angle. So if I do 180 minus 52 and minus 49, I have the third angle is 79. So if I reevaluate this with a 79, yeah, I could solve this one and get A
Or I could solve this one and get C, so that's a yes.
I should have done that for this example too. All right, let's go to the next one. See if we can speed this up a little bit. Sine of 52 over C, sine of 49 over B. That's only one unknown, okay? Yeah, I can solve that using law of sines. And this is two angles and a non-included side. Angle, angle, side. Let's look at this next one. Sine of an angle and the opposite side. I know those. I have this. I could solve for angle B first. I could set up a law of sines with these two because the only unknown is this. So that's a yes. And this is angle side side or side side angle. I'll write it that way on the paper. There's going to be our ambiguous case when we study it later and do examples like that. This triangle. I have three angles, three unknown sides. So no matter which angle I use and which opposite side, I'm going to have two unknowns. Sine of 49 over a variable, sine of 52 over a variable, sine of 79 over a variable. There's no way I can solve that. This is angle, angle, angle. This one, you can never get the sides because they could be two similar triangles, so we'll never solve it. All right, here, I have three sides. Sine of B over 9. That's a 9 right there. Sine of C over 7. Sine of A over 5. No matter how I cut it, I'm going to have two unknown angles. We do know this is a unique triangle congruence criteria, so there must be a way to solve it. But for side, 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 you can't use law of sines. You'll have two unknowns for the two angles. So we kind of can summarize here. All right, so did you get all those done? We see that for ASA, AAS, and SSA, we can use law of sines. For what triangle congruence correspondences can you set up a law of sines? All right, we can set it up for angle side angle, for angle angle side, and for side side angle. These two are clear and easy and get us an answer. This one, we're going to learn we have to deal with some ambiguousness, which we will do when I return to school the next day we are here. For what triangle congruence correspondences do we need something else to solve the triangle? Well, it looks like for SSS and SAS we need something else. We can't set up a law of sines for those kinds of examples, so you should not see them appearing in your homework for this lesson. So what we're going to do is in a couple of class periods, we'll have another lesson where we come up with law of cosines that we use for those situations. And then for angle, 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 you can't solve that because of similar triangles. It could be any size triangle with those three angles. So we will need law of cosines later. All right, that's the end of this lesson. You should be ready to practice in the homework solving some triangles with law of sines. And then the next time we meet, we'll discuss the ambiguous case for side-side angle. Have a good one. Bye.